Hello guys, welcome back to my channel, Memo African Motives. Still working on mathematics for N4 level for engineering. So in this case, we are having the question on number 1, which is actually on derivatives. That is differential calculus. So we shall be focusing on this question so that we can see how we are supposed to actually answer the question. Okay, so if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. All right, so let's quickly rush through the question. We are given the first part to differentiate from first principles if f of x is equivalent to 2 over x to the power of 4 or x to the exponent of 4. All right, that is the derivative that we are given in this case. That is the function. F of x is 2 over x to the exponent of 4. Okay, I want you to understand this, guys. We know that when we are working with the derivative using the first principle, we are going to apply first derivative with respect to x, which is equivalent to limit h is approaching to 0, like this, where we are going to have f of x plus h minus f of x over h. This is the formula that you are supposed to use, as we know. From the formula, we are going to see that there is a need for us to have f of x plus h. Already f of x is there. We've got your f of x here. So let's do this. Let's find this f of x plus h. All right. So we've got f of x plus h, which is equivalent to, we're going to substitute here. In place of x, you substitute x plus h. Okay. So it's 2 over x plus h, everything to the exponent of 4. All right. If you are to cross-check here, we are having x plus h to the exponent of 4. All right. Let's take a consideration that we want to expand this, because definitely there's a need that you're going to have, that you're going to be forced to expand this. So what are we going to do? How are we going to apply this? All right, let's just expand. We can just expand this separately here. X plus h to the exponent of 4. We just want to see what is the equivalent of that, because we're going to use it anyway. All right. So we know that using our binomial is going to be x. Remember, the concept is going to, if you are given like x plus a to the exponent of n, it's going to be x to the exponent of n plus n, x to the exponent of n minus 1, a, and so on. Plus it's going to be n by n minus 1, x to the exponent of n minus 2, a to the exponent of 2 over 2 factorial, like this. So this will be 1 factorial, of which you know that there's no effect here. So that is the consideration. All right, so let me just try to apply this using this example. So you are going to raise this x to the exponent of 4. Okay, so it's x to the exponent of 4. That's your first term. Okay, so what you have, guys, is that this first term is the one that is raised to the exponent of 4. The last term is going to be raised to the exponent of 4 at the end. So don't worry about the last term. But what is going to happen is that this first term is going to reduce its power here. It is a power of 4. So it's going to reduce its power by 1. At each stage, each and every stage, it is going to reduce by 1. All right. So what am I going to do? I'm going to multiply, as you can see here, it's n, which was the exponent here, which is 4. So it's 4x. Then you subtract 1 on this x. So you drop the exponent, then you subtract 1 here. Okay, so you're going to subtract 1. So it's 4 minus 1, which is 3. Okay, at that moment, a is going to start to appear, which is this a. In this case, you've got h. So h is going to appear, with an exponent of 1. So as you can see, if you add 3 plus 1, you must obtain 4. At each and every stage, if you add the exponents, you must obtain the exponent that you have here. So this was supposed to be 1 over 1 factorial, but there's no effect of that one, so you can just leave it, okay? Plus another stage, already we've got a 4, so you're going to start with 4, multiply by, we drop the exponent, just like what we did, we have to drop 4, so you're going to drop 3, so you're going to drop 3 like this. The moment you drop this number, you subtract a 1, so it's 3 minus 1, just like that concept of derivatives here, more similar to that concept. So you drop the exponent, you multiply by the exponent, then you subtract 1. So 3 minus 1, that's 2. So it's going to be x to the exponent of 2. At that moment, h is increasing. Remember, it was 1, now it is at 2. So it's now 2 over 2 factorial. Now there's a need for you to write the 2 factorial because it has an effect. On this one, guys, I'm saying there's no need for you to write it like 1. You can write it, but there's no effect because 1 factorial is 1. So as you can see, there's no effect, okay? So we do the same thing. We write these numbers as they are. So it's 4 times 3, okay? We drop this, and now on x we're going to drop. So you start by writing the numbers which were there, then you drop the number which is 2. So if you multiply by 2 here, you're going to subtract 1 on 2. So it's 2 minus 1, which is 1, which is just x. H is going to increase. It is now at 2, so it is increasing by 1. So it's h is increasing by 1 by 1. So h plus 1, 2 plus 1, that's 3. So it's going to be 3 over 3 factorial. Okay, plus, now we are at h to the exponent of 3, which means the last term is supposed to be h to the exponent of 4. So the last part you just write as it is h to the exponent of 4, just like the first term. There is no need, if you are to simplify, you're going to obtain h, so there's no need for you to write all those numbers. You just leave it like that, okay? So let's see what we are going to have at the end. X to the exponent of 4 is going to remain as it is, okay? This one is going to remain also as it is, 4x to the exponent of 3h. All right, so what you're going to do is to simplify this part here from your calculator. Okay, so if you simplify that part properly, you must obtain a 6 there. I don't know if it is going to be clear. There's too much light here, so that's why I'm avoiding this calculator. But it's supposed to be something like this. You put your fraction, okay? Then 4 times 3, like this, over 2 factorial. So this is your factorial. Just shift x there, which is going to give you a 6. So as you can see, that's 6. All right, so that's how you simplify these numbers. So it's going to be plus 6. This one is going to remain x squared h squared, okay? Plus, you do the same. Use your calculator to simplify this part here. 4 times 3 times 2 over 3 factorial, okay? So you're going to obtain 4, which is x and h to the exponent of 3, plus the last term, which is h to the exponent of 4. All right, so this is what you're going to have at the end. So if this is the expression that is representing x plus h to the exponent of 4, let's get back to where we actually had this part that we wanted to use so that we'll actually see its effect. All right, remember on this part here we had f of x plus h, which is the one that we said we are going to use it. But where are we going to use it? Okay, in the formula we wrote our formula here, f of x plus h minus f of x. So let's substitute. We now have everything, so now we can substitute. It's easier this way. So the first derivative is limit h is approaching to 0 like this, okay, over f of x plus h. Remember, f of x plus h, we just substituted x plus h there, and we got 2 over x plus h to the exponent of 4, if you still remember, minus f of x, which is this f of x that you're given, which is 2 over x to the exponent of 4. Okay, everything over h. This is what you're going to have. So someone is wondering, so what was the use of expanding those brackets? Okay, we are still together, guys. You see it that part. So on the numerator here, we've got these two expressions which are on top. So you are supposed to combine these. So it's easier for you to combine before substituting x plus h with the equivalent that we obtained when we expanded. It's easier for us to just combine like this. So let's combine and see what you're going to have. We've got something like this: 2 over x plus h to the exponent of 4 minus 2 over x to the exponent of 4. This is what we want to combine, the numerator only. Let's see what you're going to have. All right. If we combine this, remember guys, when you are given fractions, you have to find the LCD of the given, which is the LCD of this is going to be x plus h to the exponent of 4, x to the exponent of 4. All right. Now from this part, you're going to divide your LCM, divide by this part, which is, as you can see, x plus h to the exponent of 4. And this one will cancel. You remain with x to the exponent of 4 times 2. So it's 2x to the exponent of 4. Minus, if you divide your LCM, divide by x to the exponent of 4, these two will cancel and you remain with x plus h to the exponent of 4. But it's being affected by 2. So it's minus 2 into x plus h to the exponent of 4, like this. All right. So it means that this whole part that we are seeing here, this whole part, when you are to combine, is going to be something like this. H is approaching to 0 of, we combine these two and we obtain this part here, which is 2x to the exponent of 4 minus 2 into x plus h to the exponent of 4. This part, take note, there is this denominator here, over x plus h to the exponent of 4, x to the exponent of 4. Then we have got this h, which was already, this h is the one from the question, so it's going to be everything over h, like this. So take note, this is one fraction, this one. All right, so what am I going to do now? Look at this stage, guys. We are now back on a consideration that you are supposed to actually simplify the numerator, this fraction here. So you're supposed to simplify this fraction. But how? Remember, we have the value of x plus h to the exponent of 4. So you're going to substitute that expression. Remember this expression that we obtained of x. So you're going to substitute it now. All right, so let's do this on a separate part. I think it's going to be clear. All right, so you've got the first derivative with respect to x then, which is equal to, okay, this part is just going to remain as it is. So you've got something like this here. All right, this is 2x to the exponent of 4. That is going to remain as it is, 2x to the exponent of 4. All right, take note, I don't want to waste much time here. I just want you to see what is happening. This is x plus 4 to the exponent, x plus h to the exponent of 4, which is being multiplied by 2. And we have got the value of this x, so which means everything here is going to be multiplied by, because there's a minus 2 which is there. So minus 2 is going to affect every term here. Minus 2 is going to affect every term, each and every term, because it's outside of the bracket. So I hope you understand this, guys. Okay, so let's just affect everything by minus 2. So it's minus 2 times x to the exponent of 4, okay, which is minus 2 x to the exponent of 4, okay, minus 2 times 4, which is minus 8. So you're going to have minus 8 x to the exponent of 3h. Okay, minus 2 times times 6 is going to be minus 12, and this is going to remain as it is. So it's minus 12 h, it's x first, x to the exponent of 2, h to the exponent of 2. Okay, minus 2 and 4, which is minus 8x and h to the exponent of 3. So it's minus 8x h to the exponent of 3. All right, then it's minus 2 and h here, which is the last term, which is h to the exponent of 4. So it's minus 2 h to the exponent of 4. All right, so we have multiplied everything by minus 2, which is this minus 2 here that we had. But remember, we still have our denominator here, so the denominator is going to remain as it is. All right, so it's going to be everything like this over our denominator here, which is x as it is. Okay, do not worry about the denominator, that one, x plus h to the exponent of 4, x to the exponent of 4. So don't worry about this. So it's going to be like this. Okay, then we've got our h. Remember, the h is still there, everything over h. The h is still there. All right, these are the stages that you are supposed to actually take, which can lead us to a better answer there. Okay, so let's move on and see what is happening here. As you can see, there are like terms here. 2x to the exponent of 4 minus 2x to the exponent of 4. These two will cancel, so these two are no longer there. All right, do we have any other like terms? As you can see here, we no longer have like terms. Okay, but on the numerator here of this fraction, you can see that h is common. There is h here, there is h here, there is h here, there is h here. H is common there, so we are going to factor out that h. Okay, so let's see what is going to happen when we factor this h here. So h into minus 8x to the exponent of 3. Here we've got h squared, so we're going to remain with 1. H squared divided by h is h, so we're going to remain with minus 12x to the exponent of 2h. We are affecting h, not x. Okay, minus h to the exponent of 3 divided by h, which is h squared, so it's minus 8x h squared. H to the exponent of 4 divided by h, which is actually minus h, so it's going to be minus 2h to the exponent of 3. There were 4, so we're going to remain with 3. Okay, everything here is still under this fraction here of x plus h to the exponent of 4, x to the exponent of 4, like this. All right, then everything over h. All right, remember guys, from your fractions algebra there, when you're given something like this, 2x over 3 divide by 2, like this, what does this mean? It actually means 2x over 3, like this, divide by 2, which is 2 over 1, because it's a whole number, and it's going to be 2x over 3 times 1 over 2. So are you seeing that it's still one and the same thing to say that 1 times this is 2x over this one is same as 3 times 2. So I want you to see the effect that is happening of 3 and 2. These two numbers are actually on the same denominator if they are written like this. So it means these two can reduce with these two because they are in the same denominator. It is the same effect with this h here. This h that you are seeing in this denominator is the same as if it was written like this, not like this. So it's one and the same thing. So this h can cancel with this h. So it's the same effect that this h can cancel with this h because it's outside of the bracket and it's on the numerator. So take note, this h is in the numerator, this h is in the denominator. So these two can cancel each other. Okay, so once this h cancels with another h, you are going to see that we are going to remain with something like this, because this h is no longer there. So now we can apply the limits on this expression now. Okay, this is going to be the remaining expression where you need to apply our limits. So we are no longer having this h is no longer there. We are just left with this part, x plus h to the exponent of 4, x to the exponent of 4, like this. This is the part that you are now remaining with. From this part that we are remaining with, if you are to cross-check, now we are no longer having the h that was in the denominator. This h has no effect because we are adding. So we can apply the limits when h is equal to 0, when h approaches to 0 now. So it means every term that is h is going to be replaced with 0. So here there's a 0 here, a 0 here, a 0 here, a 0 here. All right. So as you can see, this term is going to be eliminated, eliminated, eliminated. So on the numerator, you're going to remain with minus. Okay, let me write it here. On the numerator, you are going to remain with minus 8x to the exponent of 3. So we are no longer writing the limit because we have applied the limits now, that when h is approaching to 0, this is no longer there. You are now left. So you are no longer writing this part because you have applied the limits. Okay. On the denominator here, if we apply the limit to say h is equal to 0 or h approaches to 0, this is going to be x plus 0 here. Okay, let's take this from normal numbers. 2 plus 0 is a 2. So x plus 0 remains as x. But there's an exponent of 4 which is outside. So it's like this. So it's going to be x plus 0, which is x, to the exponent of 4. Okay, and this x is going to remain because there is no h here. So it's going to remain as it is, as x to the exponent of 4. All right. So can I leave my answer like this and say I'm done? Fine, I'm done. No, guys, we can reduce x to the exponent of 3 and x to the exponent of 4. We are going to remain here with 1 and here with x because there are 4 here. So we're going to remain with 1x. So therefore, the first derivative with respect to x is going to be, on the numerator, you are left with minus 8 over x to the exponent of 4 times x, because there's an x, this one, and you know that when you are multiplying the bases which are the same, you're going to add the exponent. So it's 4 plus 1, which is 5. So you're going to remain with x to the exponent of 5. So this is what you're going to have as the first derivative with respect to x, minus 8 over x to the exponent of what? Of 5. So as you can see, guys, it's a funny question that you have to play around with a lot of things, the binomial theorem, expansion, then the application of the first principles itself. You have to be knowing it to the limits. So that's how they can actually ask these questions. So in exam, that's how you're supposed to answer them. Okay, the other question is to differentiate the y is equal to square root of 5x plus 1 by using chain rule or function of a function. Okay, I actually referred to something of this sort on function of function. If you still remember from one of the classes, if you were following, when I talked or referred to function of function, actually is something that you're supposed to be used to when you are working on what? On derivatives, or that is differential calculus. We know that function of functional chain rule is something that you're supposed to apply, where we can rewrite this 5x plus 1, the square root. We know that is written as, can be written as to the exponent of a half, like that. So we know that from the formula, actually the function of a function states that we are supposed to apply the formula of dy dx, which is equivalent to dy du times du dx. But where are we going to have this dy du dx? We are going to introduce here from this part we can let this 5x plus 1 be equal to u. So we can let u be equal to 5x plus 1. All right. That means by letting u be equal to 5x plus 1, it means now our y is equal to, in place of 5x plus 1, we are now representing with u. So it's now u to the exponent of a half. This is now what you are having there. Take note about this stage. All right. So how is it important? Because as you can see here, we have y, the derivative of y with respect to u. So you're supposed to find y with respect to u with respect to x, u with respect to x. Okay, so let's find the derivative of u with respect to x. This is going to be 5. Okay, this one is a 0. So there's nothing that you're going to get there. Okay, derivative of y with respect to u is going to be, so take note, there's an exponent, you drop the exponent, which is half, we subtract 1, so half minus 1 from your calculator, this one is a negative half. All right, which we know that when you are given a negative half like this, is same as 1 over, so you can write this as 1 over, already there was a 2 which was in the denominator, so it's going to be 2 u to the exponent of what? Of a half, which is actually the same as 1 over 2 u to the exponent of a half is same as square root of what? Square root of u from your exponents, guys, if you still remember. So this is same as what? The square root of a half, or the square root of u. So now let's come back here and substitute what we obtained, dy dx. Now it's a derivative with respect to x, not with respect to u, it's with respect to x. So my answer is supposed to be in terms of x. Okay, so dy du, this is our dy du here. Yes, it was y with respect to u, that is our answer, is having a u here. It's true, because this is y with respect to u, but now I need y with respect to x, so which means I'm supposed to substitute this u with that part which carries x, where I said let u be equal to 5x plus 1. So I'm going to substitute now in place of this u with 5x plus 1, so it's going to be 1 over 2 square root of 5x plus 1, like this. Take note at this stage, guys. Multiply by du dx. Okay, du dx, this is the part that we obtained here. Du dx gave us 5, so you're going to multiply by 5. Okay, so that means therefore your dy dx can be, if you can multiply 5, because this one is same as 5 over 1, so you can multiply the numerator and the numerator 5 times 1, which is 5 over 1 times 2 square root of, it's going to be 2 square root of what? Of 5x plus 1. Okay, so this is going to be your dy dx. So as you can see, guys, that's how you are supposed to actually apply these derivatives. So as you can see, differential calculus is something that is clear, is something that you can actually apply the concept from the normal concept of derivatives. Okay, so you're supposed to revise at least as much questions as possible. Okay, then on 1.3 we are asked to differentiate. Take note, guys, it's y in if x is equal to, okay, differentiate in terms of y. Take note here, it's in terms of y. This expression is written in terms of y. Okay, most of us, we are actually used to a condition where it is in terms of what? In terms of x. Okay, so I'm actually looking for this part here, so it's like this. All right, this is what we had. So in order for you to find the derivative, it's supposed to be actually the derivative of x with respect to y, like this, dx dy. This is what you're supposed to do. So normally I always like to first rewrite this, so we can actually rewrite these expressions when we are differentiating them. It's going to be easier. All right, so let's find the first one, dx dy. So as you saw that this is actually having 5 marks, so each and every part is going to be having 1, 2, 3, 4, 5. Yes, each and every part is going to be having a mark. So that means here you're differentiating ln. Okay, remember guys, when you're differentiating ln, is the derivative over the function that is on ln. So the derivative in this case of minus y is -1, okay, over the function of y that is given, which is minus y, like this. So it's going to give us 1 over y. So we're going to have 1 over y in this case. Okay, we have 4a to the exponent of 3. As we can see, there is no y here. So just like, okay guys, I don't know what's happening here. So just like a normal derivative, we know that when you are finding the derivative, when you're given a constant, it's going to give you a 0. Okay, so this is going to be -0. Okay, then we move on. In this case, we have got minus 2 pi cos y. So from this derivative, what am I going to obtain? Remember, the derivative of cos is sine, so it's minus sine, so it's going to be minus this minus and the minus for sine, so it's going to be a plus. So it's going to be 2 pi sine y, like this. Okay, then we have got a ln here, but let's first see what we have on this ln. It's let's first write it aside. It's ln y to the exponent of 3 over 4, like this. Okay, which can actually, this one can, remember from our laws of logarithms, this is same as 3 ln y over 4. It's one and the same thing. So it's actually the same thing as 3 over 4 ln y, like this. It's one and the same thing. To write 2 over 5x is equal to 2x over 5. It's one and the same thing. You can actually rewrite like that. Okay, so it means that if I can rewrite as 3 over 4 ln y, I can now find the derivative of ln, where I know that the derivative of ln y is going to give me 1 over y. So it's going to be 3 over 4 times 1 over y. Okay, so we are going to have minus, because there was a minus there, minus 3 over 4 times 1 over y, like this. Okay, we move on to 1 over the square root of 4y. Okay, so let's first write it down. 1 over the square root of 4y, like this. Okay, the square root of 4, we know that is 2, so this means 1 over 2, but we can't determine the square root of y, so it's going to be the square root of y, like this. Okay, now we have got 1 over 2 square root of y, but square root of y, we know that is the same as y to the exponent of a half, which can be written as 1 over 2, like this, y to the exponent of minus a half, because this y is the one that you want to find its derivative, not this half. So this half is not going to be affected. Okay, so here we are just rewriting. We are not finding the derivative, we are just rewriting. Now the derivative with respect to y of this is going to be, remember, we have to multiply by the exponent. So we already have 1 over 2, like this. We multiply by the exponent, which is minus 1 over 2. Then it's going to be y to the exponent of, we subtract 1. Multiply by the exponent, we subtract 1. So minus half minus 1 from your calculator is going to be minus 3 over 2. Okay, so this is going to be minus 3 over 2. Okay, so if you multiply this properly, it's going to be minus 1 over 2 times minus half from your calculator is going to be minus 1 over 4. Okay, so you're going to obtain minus 1 over 4 y to the exponent of what? Minus 3 over 2. Minus 3 over 2 like this. But as you can see, guys, it's just 1 mark, 1 mark, 1 mark for each part. So actually there is no need for you to simplify further. You can just leave your answer like this because it's just a mark for that. So that is what you had to do on this question. All right, so I hope you see how you actually attempt such typical questions, because they will actually ask such type of a question. Okay, the other question we asked to prove that the coordinates of the turning points of that function of y is equal to x to the exponent of 3 minus 2x minus 4 we are given the coordinates respectively. Also determine the points of inflection using the second derivative. Okay, so we want to determine the coordinates of the turning points. All right, we are given that y is equivalent to x to the exponent of 3 minus 2x minus 4. Okay, so we know that to determine the coordinates of the turning points, the derivative of y with respect to x should be equal to 0. All right, so let's find the derivative of y with respect to x. So this one is going to be 3 x to the exponent of, we subtract 1, which is 2. So it's 3 times 1, which is 3. Then you subtract 1. Okay, minus 2x, guys, remember, it's going to give us minus 2 because x there. Minus 4, the derivative of minus 4 is a constant, so it's going to give us a 0. Okay, so that's what we have here. So we know that the derivative should give us a 0 there, the first derivative. So 3x squared minus 2x minus 2, sorry, should give us a 0, this one. 3x squared minus 2 is equal to 0. So let's solve for x. 3x squared is equal to transpose minus 2 to the other side is going to be positive 2. Then how can I find x? Actually, I can divide both sides by 3 by 3 by 3 here by 3. So it means x squared is going to be 2 over 3. All right, so what am I going to do to find x? Introduce the square root because it's x squared. So your x is going to be, remember, square root of any number, guys, is plus or minus. So you're going to obtain two values. So use your calculator, determine this. Inside the square root, you're going to obtain two possible values there, which is 0.816. If you round off properly, the number that you're going to obtain is going to be plus or minus 0.816, like that. So from these two possible values, as you can see, it's a plus and it's a minus. You are going to now to find the values of y from this normal, okay, from this normal function. So that is where you are going to substitute. So y is equal to x to the exponent of 3 minus 2x minus 4. Substitute there, so it's 0.816. Start with a positive to the exponent of 3, okay, minus 2 into 0.816, like this, minus 4. You obtain a value from this one. You do the same with the negative, minus 0.816 to the exponent of 3, minus 2 into minus 0.816 minus 4, like this. So this is the presentation that is supposed to be in your calculator because you are substituting on these two. Okay, so on this one you are going to obtain minus 5.8. okay, make sure that you substitute properly, guys. You're going to obtain minus 5.0819. right? Then this one you're going to obtain negative 2.911. all right, so it's because of this light that I'm using. There's too much light here, so therefore the coordinates here is going to be 0, so you just write these coordinates properly. 0.816, okay, that's the value of x, and the value of y at this point is minus 5.089. okay, another point is at negative 0,816 when y is this value, which is minus 2,911, like this. Okay, so these are the two possible values of y of the turning point. So sometimes they can even ask you to distinguish between these, that is to determine the nature of the turning point, whether it's a maximum or it's a minimum turning point. Okay, we shall see that type of a question so that we can actually work on it. But the other question here was actually asking us to determine the points of inflection using the second derivative. Okay, we know that to determine the point of inflection using the second derivative is supposed to be the second derivative is equal to what? Should be equal to 0. Okay, so remember that we have got the first derivative. We obtained this as this was 3x squared minus 2. So let's find the second derivative now. So the second derivative with respect to x, you are simply continue. You are going to continue to differentiate. So you multiply again 2 times 3, that is 6x. You subtract 1, so it's going to remain as 6x. So this is your second derivative, 6x, which is equal to 0. So divide by 6 by 6. X is going to remain as x is going to give us a 0 there. Okay, so remember it's a point where I have to find the value of x, which is a 0 there. Then I substitute this, so I'm going to substitute back into the normal part here, which is the normal function of x cubed as it is. So when x is equal to 0, it's going to be 0 to the exponent of 3 minus 2 into 0 minus 4. Okay, so from your calculator you are going to obtain -4. Okay, so this is the point of inflection that you are given, the coordinate of the point of what? Of inflection. So that's how, guys, they ask these questions. So you're supposed to be very, very familiar with these typical questions before exams. You're supposed to be very, very familiar so that you'll be able to attempt such typical questions in exam. So that's it, guys, working on mathematics for N4 level engineering. So just make sure that we revise as much questions as possible before exams. So that's it, guys, from Mason African Motives. Till we meet again.